This is a video on finding the maximum error in Simpson's rule. The question states, determine the maximum possible error in using Simpson's rule with n equals 20 to approximate the integral from 2 to 3 of 1 over 1 minus x dx. So we'll use the error formula for Simpson's rule, which states that the error is always less than or equal to b minus a to the fifth divided by 180 n to the fourth times the maximum, and this symbol means the fourth derivative of x for x between a and b. So a and b and n, those are all easy. That's just 2, 3, and 20. But the fourth derivative, we have some work to do. So the function is 1 over 1 minus x, and since we're taking a derivative, it's easier to write it in exponent form, 1 minus x to the negative first power. So now let's take the first derivative. We use the chain rule. The derivative of the inside is negative 1, and then it's times negative 1, so the negatives cancel, 1 minus x to the negative 2. Now let's take the second derivative. The derivative of the inside is negative 1 again, times negative 2 times 1 minus x to the negative 3. Negative 1 times negative 2 is 2, and there's our 1 minus x to the negative 3. Now let's take another derivative. So we take the derivative of the inside, which is negative 1, times negative 3 times 2 times 1 minus x to the negative 4. And negative 1 times negative 3 times 2 is 6. So we have one more derivative to take, the fourth derivative. And again, same chain rule. We get negative 1 times negative 4 times 6 is 24 times 1 minus x to the negative fifth power. And there's our fourth derivative of x. Now we need to find out what the maximum possible value is in between 2 and 3. So note that 1 minus x to the negative fifth means that we're going down in a denominator. We're taking absolute values. So 1 minus 2 is negative 1. And then if we're bigger than 2, then we're going to be smaller than negative 1, closer to, say, negative 2, and that's going to make this denominator larger. So the very maximum this fourth derivative could be is when x is equal to 2, and then you get 24 times negative 1 to the negative fifth power in absolute values, which is just 24. So we could say the maximum of the fourth derivative between 2 and 3 really is 24. Now we can plug in all our numbers. We get that the error is less than b minus a, or 3 minus 2, to the fifth power, divided by 180 times n, or 20, to the fourth, times 24. So the last step is to just put this in a calculator, and what I got is 0.000000083. And we can see that Simpson rule is very accurate when n is equal to 20. And I'm done with the problem.